is a very good question, and as I told you earlier, in these kind of sums, the first step is very important. Possibly keep the right hand side in your mind. We want to get 1 plus a square plus b square plus c square. Now what should we do? Directly does not strike anything what to do. You know, if you look at this A11 element, a square plus 1 is there. So if somehow, either by adding a multiple of column 2 and multiple of column 3, if you could get b square and c square. Here you already have AB. AB multiplied by what will make it b square? AB multiplied by b by a. A will cancel, you will get b square. Similarly, that is in column 2. Similarly, in column 3, you have AC. What if you multiply it by c by a? A will cancel and you will get c square. So at least we find that in the first column, A11 element will become 1 plus a square plus b square plus c square. Let's try whether the other elements will be so or not. So the instruction is apply C1, replace C1 to C1, that is add to C1 b by a times C2 plus c by a times C3. You get C1. Now what is b by a times, as I have shown you here? So you already have a square plus 1. Now you are adding b by a times ab. So that is b square. So a square plus 1 plus b square, and c by a times ac gives you c square. So here in A11 place we get a square plus b square plus c square plus 1. Now let's add the second element. Here you already have AB. So let me just first write plus b by a times the C2 element, that is b square plus 1, and plus c by a times you write BC. So let me first write it as such. And what is the third element? Now we are adding to the column 1. So column 1 properties of element in the following. Column 1 determinant equal 1 minus the third one. Third one is CA and plus b by a times what? B by a times c by a into b by a. Sorry, not c by a, it was CB. BC plus b by a. And plus you get c by a times the third column, so c by a times c square plus 1. This will simplify in the next step. And keeping the other two columns as such, that is AB b square plus 1, CB, and the third column elements are AC, BC, and c square plus 1. Now in the next step, let me just simplify the elements of C1 somehow. No doubt this 1 element is 1 plus a square plus b square plus c square. Now do you find that here b is throughout common? So take b common, and taking a LCM you get a square. So rather you take first a as LCM and take b by a common. That step I leave for you, that out here you take a LCM. So then by taking b by a common, you will left with a square plus b square plus 1 c square. I'm sure you can do it. Similarly, for A13 element, you take LCM, a as LCM, and then take c by a common. So you get a square plus b square plus c square plus 1. Yes, we have got that in column 1, at least you have a common factor 1 plus a square plus b square plus c square. Next step will take it common. And keeping the other two columns as such, that is AB b square plus 1, CB, AC, BC, c square plus 1. And what is the next step? You take 1 plus a square plus b square plus c square common from C1. So you get 1 plus A square plus B square plus C square out, and you get, in the first column, you left with 1 B by A, C by A. In the column 2 and 3, still the same, AB, B square plus 1, CB, and the third column is AC, BC, and C square plus 1. What do you find now? That from column 1, we can take, from column 1, you take A common, 1 by A rather. So because 1 by A is there in two places, so when you take 1 by A common from 1, that will make it A. So now, taking 1 by A common from column 1, and you see you take B common from column 2, taking B common from column 2 and C common from column 3. Why we are doing so? Because then you will find all the three elements in row will become A. That will help you. So now taking 1 by A common from column 1, what do you get? Already you have 1 plus A square plus B square plus C square. What are we doing? We are taking 1 by A common from column 1, B common from column 2, and C common from column 3. And you left with 1 by A common from column 1 means 1 divided by 1 by A will make it A, and of course B and C here you get. Then taking B common, you will left from column 2, you will left with B, but B square plus 1 divided by B will make it B plus 1 by B, and you are taking B common from column 2, so the first element of column 2 will be A. And in the last, the third element of column 2, you are taking B common, you will left with C. And finally, from column 3, you are taking C common, so you are left with A and B, and you will get C square plus 1 divided by C will make it C plus 1 by 3. And now we are very near to the answer. What do you do? That, because in row 1 you have A, so if we apply C2 minus C1 and C3 minus C1, we will get 2 zeros, and it will be easy to expand them. So you apply, change C2 by C2 minus C1, and C3 also C3 minus C1. What do you get? Already outside you have 1 plus A square plus B square plus C square, and into BC by A. This is already there. And now applying C2 minus C1. So at least column 1, that is ABC, is there. Now by applying A2 minus A1, you get A minus A 0, and 1 B plus 1 by B minus B will give you 1 by B, and C minus C gives you 0. Then applying C2 minus C1, you get, then applying C3 minus C1, you get 0, 0, and 1 by C. And now it is simple that you expand it along row 1. Expand the determinant along R1. What do you get? 1 plus A square plus B square plus C square into BC by A. This is already there. And when you expand it along row 1, you get A times 1 by B into 1 by C, 1 by BC, minus 0, and rest of the two elements, of course, will be 0 each. So you left with 1 plus A square plus B square plus C square into BC by A, and from inside the bracket you left with A by BC. So what happens? So simple, A and BC cancels, and here you are with the required result, 1 plus A square plus B square plus C square, which is the required right hand side. Question 15. Choose the correct answer. Let A be a squared matrix of order 3 by 3, then the value of determinant Ka is equal to, though I have discussed this some earlier, But let me discuss now independently. You know, given is a matrix of third order, so let the matrix is, say, A1, A2, A3, B1, B2, B3, C1, C2, C3. If this is the given matrix of order 3 by 3, then what will be matrix Ka if scalar multiplication? When you multiply a matrix with a scalar, non-zero real number K, you know, in scalar multiplication of matrix, you have to multiply each element by K. So you will get in turn K1, K2, K3, KB1, KB2, KB3, KC1, KC2, KC3. This is your matrix Ka. So what is determinant Ka? Determinant Ka is determinant Ka1, Ka2, Ka3, Kb1, Kb2, Kb3, Kc1, Kc2, Kc3. And you know the property that in a determinant, if a number is common in any one row or any one column, we can take common, not throughout, not from each element. You can take common, a number you can take common only from one row or column. So let us take K common from row 1 and K common from row 2 and as well as K common from row 3. So what do you get? Outside K into K, K cube times A1, A2, A3, B1, B2, B3, C1, C2, C3. So you get K cube times determinant A. So which choice is this? K cube times determinant A? That is your C part. So C part is the correct answer. Question 16. Which of the following is correct? Determinant is a squared matrix, no doubt. Determinant is a number associated to a matrix. Determinant is a number associated to a squared matrix. None of these. So which one is the best choice? Determinant is a number associated matrix, can be of any order? No. Because determinant is always for a squared matrix. But determinant is not equal to square matrix. To every squared matrix a determinant is associated, but square matrix itself is not a determinant. What is it then? Determinant is a number associated with the square matrix. So C part is the correct answer.